Hello, this is video number 13. We are still looking at the C++ solution to the OilField problem. Let's look at the header file. This is OilField with capital O, because we're defining a new data type, .h, the interface file. Starting again, I hope you've got a copy to look at. Try to get either a hard copy or open oilfield.h in your editor or whatever. Standard header stuff, interface, oilfield class, yada yada yada, if and def define. IO stream, F stream, we need all that stuff. Where's something interesting? Class oilfield, no. Constructor, destructor, of course we got those. Aha, line 22. So if I start a line list over here, line 22. What's interesting about that, in my mind at least? That's the first time we've seen a parameter of type reference to an input file stream. Let me see if I can remember all of that. Parameter, abbreviated, parameter of type reference, I'll abbreviate REF, reference to an input file stream. And we'll use this used as replacement for CN when we want to get input from the file. We don't have to do anything magic. Just where we would have used CN to read something from the keyboard, we're going to use our parameter InFile to read it from our open file on disk instead. Now, if you're thinking about this real hard as you're writing it down, you might well wonder, well, why do I send that not only as a reference, but not even a constant reference? If all I'm doing is reading from this input file, then certainly I must have no business trying to change the contents of that file. That was a very insightful thought you just had there. Why should that be passed by reference? Well, technically, ifstream, the variable ifstream, is not the actual file on disk itself. It's an internal object of type ifstream that corresponds to that file. Here's what it's going to do. When we're ready to start reading from the file and say, give me something from InFile, it actually pulls a bunch of stuff, bunch of bytes off the disk file from oil.txt into, get this, into a bounded buffer inside the ifstream object. So it is going to have to change the ifstream object just in the normal process of reading that file. So it's got to read in some bytes into, it's just a big array. It reads in bytes off the disk into the big array, the bounded buffer that is one of the fields, one of the members, one of the private variables inside the ifstream object. Not only that, it's got an internal, well, it's called a cursor, but it's really just an index number. It's got an internal placeholder of where the next byte to read is. So that if we read from this file several times, it's not always going to go back and start reading with the very first byte every time. That was a very long-winded justification for why we have to pass in ifstream by reference. The contents of that input file stream object in memory is going to change, even though it's not going to change the contents of the file on disk. Yeah, that's way more mileage than I meant to get out of that. That was line 22. It's a reference to an input file stream. Enough said. Oh dear, look at what we are headed toward. Clean? No, that's no big deal. No parameters, no return values, so clean does whatever it's going to do. These are these are mutators, by the way. I didn't, yeah, I did have mutators over there on the right in the comment. It's an unusual place. I guess I was trying to save paper. Find all deposits, returns an integer. We know what that's going to do. It's going to count how many deposits it finds and returns an integer. Done. There. Now we've gotten there. 25. 25. Oh my goodness. OilField ampersand. That's the return type. It's going to return a reference to an OilField object. Operator equals. There's the weirdness right there. Notice there's not a space between operator and equals on line 25. We're not setting the word operator to equal some new value. No, no, no. Operator equals, all one word, that is the name of the function that's called when we try to use the plain old assignment operator on a type OilField object. Let me say that again. This is an overload of the assignment operator. We can actually overload any of the operators we want to. We can overload double equals. We can overload greater than or equal to. We can overload any of that stuff we want. This is overloading the assignment operator, meaning we are providing a new alternative definition for the assignment operator for when it is used between two objects of type OilField. All one word. In the editor I printed this out from, it actually changed operator to the special color. That's a reserved word. You have to use it just like that. Lowercase o, spell it correctly. Operator equals is all one word in the mind of the computer. That is the name of the function that's called for our assignment. The parameter. Here it is a constant OilField reference. And I just called the parameter variable other because it is. It's an other OilField. You could call that anything you wanted. But const, we're passing the other one in by reference, but we're not going to be able to change it. And if you think about that real hard, you realize, well, you know, that makes sense. Copying from variable x over to variable y, that should change perhaps, or certainly, should change the value of variable y. It has no business trying to change the value of variable x. So whatever's on the right-hand side of the assignment operator, in fact, other is a stand-in for what's on the right-hand side of the operator. That's what we're going to be copying. And the object that we're inside right now, that's the one that's going to get the new value. So we are calling a member function called operator equals on the current object. And I can't possibly write all that down. The assignment operator, on line 25, the assignment operator, OPR for short, oops, is overloaded as a function. Overloaded specifically as a mutator member function. Got to be a mutator. It's got to change where we are. We're copying somebody else into us. Mutator member function. I kicked the board. I hope it's still right in place on the screen. Why? Why do we do that? Well, this is a homemade data type. We, as the coders of the OilField class, we must define with this function what it means to copy one OilField object to another. Now I keep mapping back the one class that we know oh so well. If we had an overloaded operator for the linked list class, we would have to copy, actually we'd have to dynamically allocate one matching node for every node that was in the other list. We take a good hard look at other, where the cursor is, where the head pointer's pointing, where the tail pointer, and just clone that, make a complete copy inside us, the home object, for the linked list that is on the left-hand side of the assignment operator. I know this is tricky and complicated. You might want to back this up and listen to it again. Let me read 25 again. The assignment operator is overloaded as a mutator member function. We are declaring in this header file that we are going to provide our own definition for the assignment operator for our own homemade data type, the OilField with a capital O. We have to define what it means to copy one to the other. We could actually make it anything we want. It's not going to be very effective unless we actually create a clone. But we could still do it any way we wanted. You know what? Let me do this. Draw a line, change the color. I don't know whether this is a fig or an example or what. I'm going to call it an example. That's blue, by the way. That might look exactly like the black. But let's say in a main program we've got two oil fields in main. Well, actually, it doesn't have to be in main. It could be anywhere. But oil field with capital O, so that's a data type. Oil 1, comma, oil 2. Just like we had in the driver program, except I didn't call them that. I think it was what? Oil field and backup oil field or something like that. I don't remember. So I'll make up new names. I can remember these. Oil 1 and oil 2. There. Oh no, I need to copy oil 2 into oil 1. What you type will be this. I'll put a comment. What you type, if we've got this overloaded operator up and running, then that's easy. Oil 1 equals oil 2. The end. That's not what the compiler sees. I'll switch color and even put this in the box because this is not going to be code in our main program. What compiler sees? Whoops, that green doesn't show up. Green seems to be the first one to dry out. That must be an evaporative color. What? No. Dark green. Maybe that'll do. What compiler sees? We're innocent. We overloaded, or someone did it for us. The operator got overloaded, the assignment operator, so that we could do this simple thing in the main program. What this is, think about this real hard. What this is a function call to a mutator member function on the oil1 object, and we're passing in oil2, another OilField object, as a parameter to that member function. That's the overloaded equals operator. Yes, it is that complicated. Sorry about that. What the compiler sees is this. Oil1 dot. What member function is being called? The member function called, all one word, operator equals. O-P-E-R-A-T-O-R. Operator equals. All one word. I'll even put a bracket under it. It looks like, I know it's visually confusing, it looks like we're assigning something to this. We are not. All of that together is the name of a function, and we're passing in one parameter. Oil2, semicolon. If you don't believe me, take this line out. This is still valid C++ syntax, by the way. You could take this line out and put this in its place. Translates to exactly the same machine code. Does exactly the same thing. This, because it's a homemade data type, it's going to look around. Oh no, I don't know how to do the assignment. Did they provide an overloaded assignment operator for me? Yes. It will look in the header for the class and find out, yes, indeed. There is an overloaded assignment operator in the oilfield.h interface file. All these words. So this was going to go in a box. That's what the compiler sees when we type that. Okay. There's actually not a whole lot of extreme interest, or perhaps even mild interest in the rest of that file, but there are things I want to mention at least in passing, so I'm going to get rid of this. Still line numbers. You know what? Since you've got this anyway, I'm just going to clear the whole board. Still, oilfield.age. A couple more lines to go. What else we got? Lines 33 through 37. Through 37 are what's called an enumerated type. Let me say that with a clear throat. Enumerated type. E-N-U-M-E-R-A-T-E-D. Enumerated type. That is a C++ weirdo if ever there were one. This is actually not the classic use of an enumerated type. You set up an enumerated type that is a data type in its own right, but you list all the possible values and what those values correspond to back in the real world. If that doesn't make any sense, then don't even worry about it. What it provides here, and what it provides in just about every place I've seen it in C++ code, because it's not very popular, this is a fast and nasty way to set up some symbolic constants. Fast and nasty way to set up a bunch, B-U-N-C-H, a bunch of symbolic constants. And you know what symbolic constants are for. A lot of things. They're to make it so you can change it in one place, it's changed throughout the program. They're made so that it's self-explanatory. For example, 100 is there twice, max width, max height. Each one of those means something different in the program. I can change one without changing the other. So that's a fast and nasty way to not have to do const int max width equals 100 in the header file and expose that constant to perhaps malicious intent by other files. So there are 4 constants here. Max width is 100, max height is 100, oil char is @, empty char is the star. Now, let's see. Unlike const, though, I said this is fast and nasty way to skip by const. I'll point this out. Unlike const, these values have no associated data type. And that, you know what, I've prefaced this comment on several things now. That's kind of hard to explain. Well, let me see if I can explain that. Unlike constant, in other words, since this is an enumerated type, since we're providing the only 4 things that make any sense in this brand new weird little data type, max width is 100, but max width is not necessarily an integer. In other words, it's just plain, unadulterated, unfiltered 100. And that's why we can get away with using several different data types there inside the same enumeration. Oil char, I give oil char a value inside single quotes. It looks so much like a character, except oil char itself, that symbol oil char, is not technically a character value. It's a subtle thing. You don't really have to worry about it. All we got to worry about is, well, I need to remember oil char, empty char, and all those things later on in my program. So this is a fast and nasty way to get all those symbolic constants set up in one place so that they're available down in the CPP file. I am not satisfied with that explanation at all. Just remember, though, that we are going to have to do something a little special if we want to guarantee that max width is actually interpreted as an integer rather than just 100. Same thing with oil char. We might have to do something a little special to make the system see that as a character value rather than just a symbol that corresponds to an @ sign. I'm still not satisfied with that. You know what? I'll move on. How about line 40? Line 40. That's a 2-dimensional array. Can't spell dimensional. 2-dim array. And max height, we just now saw that. That's 100. Max height is the number of rows in our 2-dimensional array. Max height is rows in array, and it takes a long time to write these out. Max width is columns don't trout, columns in the array. So there, if you've never seen a 2-dimensional array before, you have now. It's no big deal. It's just that whenever you want to access one particular little square in your 2D grid, it's no longer a linear data structure. It's a 2-dimensional data structure. That's why it's called a 2-dimensional array. Cool how that works out. You've got to specify two indices rather than just one. So rather than just square brackets I, you might have square brackets I, square brackets j. Each one of those is enclosed in square brackets separately, as we shall see when we see these used in actual code. What else? That's a lot about just the header file. Let me see. The constants are the weirdo symbolic constants enumerated type. The variables, we've got a 2-dimensional array called grid, where we're going to load the region out of the input file. And 3 more variables. We've got rows and columns. You know what? Deposits? Yeah, I guess I do use deposits. That's probably going to be my counter. I couldn't remember whether I used deposits in the implementation file or not. And then look, there's a private function down there. Now, you don't have to look very far to realize, you know, that private function is not technically a private overload. There is no public function named dry up. Originally, I did have the public wrapper, which is named Find All Deposits, up on line 24. I also had that on line 44, but I changed that to dry up so it feels much more like we are focusing on one square in the grid, which is exactly what dry up is going to do. Dry up doesn't know it's finding all deposits. Oh my goodness, that's not my job. So they're going to behave very much like a public wrapper and a private overload, but just for clarity, I changed the name of the private overload to dry up because it's going to dry up one square. If it's got oil, it's going to leave it alone and return nothing if there is nothing there. And I think I've beat this header file to death. I hope. If you have questions, come by during office hours, make an appointment, note them for class, speak to your coding buddy, yada, 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 and I will see you online.